Good morning, good afternoon, good evening. Whatever the case may be, we are back and better than ever by the great Orinoco Flow. This is Exam Jam number 9, the solution. Let's get to it, shall we? I thought it was an easy 20 points. Hopefully you thought the same. So here we go. A, find a vector equation for the line L1 which passes through PQ. Well, it's so easy. We just need a point and direction. We got a plethora of points, and the direction is going to be in the direction of vector PQ, which is going to be 5 minus negative 3, 5 minus negative 1, and then we make this bigger, and I'm going to go on the paddleboard tour later today, I suppose, and 6 minus 2. And that is going to give us 8, 6, 4. Okay, we could divide those by 2 if we wanted to. Doesn't matter, but we end up with R is equal to either one of these points. We won't be rebels. We'll go ahead and choose the first one. 3, negative 1, 2, plus T times the directional vector. 864. Booyah. We have some easy points. I'm not sure what it's worth because I didn't do the point thing. All right, so B. Let's do B. We have another vector. It has this equation. Show that L1 and L2 intersect at this point. Okay, so I have this vector equation for L1. I'm going to put that up there just to remind me that this is L1. And this is L2, and where they intersect, their coordinates are going to be the same. So I am going to look for a 0 somewhere. I like this one. Remember, R can also be written as x, y, z here. So x equals negative 4 plus 5s and so on. Again, here x, y, z could also be written. So I know that 4 plus s times 0, 4 plus s times 0 is 0, must be equal to this z coordinate, which is 2 plus 4t. Okay, and we solve that, and what? 2 equals 4t, so t equals 1/2, which means I substitute back in to the vector equation of the line that has the parameter t, and I can get my coordinates. X is going to equal negative 3 plus 2 times 8. Wait, I feel like I'm doing something wrong here. What am I doing? Oh, 2. I'm such an idiot. It's 1/2. Negative, that's what I'm doing wrong. Negative 3 plus 1/2 of 8. Negative 3 plus 4 is 1. Y is going to be negative 1 plus half of 6, so negative 1 plus 3 is 2. And Z is going to be equal to 2 plus 2 or 4. Okay, so it says, okay, so we've shown it. They gave us the answer here, and we've shown it. So I guess we could write implies 1, 2, 4, but just doing this is enough. All right. And part C, find the acute angle between L1 and L2. Here's the direction of L1. Here's the direction of L2, but I'm going to simplify that just to make my life easier. And I'm going to say that theta is equal to the dot product of these guys. So just off here, I'm going to, just so I don't mess up, that's going to be 4, 3, 2. Same direction, just makes my multiplication a little easier. So 5 times 4 is 20. Dot product here. 2 times 3 is 6. And 0 times 2 is 0. All over the magnitude of these two vectors. So square root of 16 plus 9 is 25, plus 4 is 29, so root 29. And I prefer taking I-4. Route 29 always has a lot of traffic jams, so I avoid it. Square root of 25 plus 4 is root 29. Theta does not equal this at all. Theta equals the arc cos of that, boys and girls. That's not my fault, it's yours. And we crank that in the calculator and we get 26.3 degrees. Isn't life grand? D, here we go. So D, so S is S is a point on L2 such that mag RP equals mag RS. Show that one of the possible positions for S is S1 negative 4, 0, 4, and find the coordinates of the other possible position S2. All right, so let's get to this. So I know that RP is equal to what? Where's R? Here's R, and here is P. So vector RP is going to be equal to, let's see, negative 3 minus 1 is negative 4. And then, I keep messing up. Okay, oh, negative 1 minus 2 is negative 3. And then 2 minus 0 is, I'm sorry, not 2 minus 0, 2 minus 4 is negative 2. Okay, so I got that going for me. And I know that mag RP then would be equal to root 29. And showing that S1 is on 4, negative 4, I'm going to find the mag of RS, okay, or RS1. So RS1 would be equal to, so negative 4 minus 1 is negative 5, and then 0 minus 2 is negative 2, and then 4 minus 4 is 0, right? And so mag RS1 is also equal to root 29. 25 plus 4 is root 29. So I have shown it. Isn't that dandy? Okay. So now let's think about this. Show that one of the possible coordinates for S is negative 4, 0, 4, and find the coordinates of the other possible point S sub 2. So S sub 1 and S sub 2 are on the same line, right? As is R, because R is the intersection point of L1, 2. So they're all on a line. So I have a situation here where I'm going to have R in the middle, and I'm going to have S1 on one side and S2 on the other side. Why do I tell you that? Well, because if this is true, if you can imagine the origin, the vector OS2 is going to be equal to OR, yes, plus S, the vector S1R. Think about that. So I don't know, say the origin is here. OS2 is going to be equal to vector OR, right? And the vector RS1 goes this way, but if it goes this way, it's going to go right to S2. And remember, adding vectors geometrically, it's from start to the finish point, and then we we get OS sub 2. Well, this is easy peasy because the vector OR is equal to 1, 2, 4. And then the vector S1R, I'll let you work that out. Or do we already have it? It's 5, 2, 0. So that is equal to 6, 4, 4. The vector 6, 4, 4. And so from the origin, I can imply that S sub 2 is 6, 4, 4. Giddy up. And I'm going to show you that actually. Just so you get a picture of it. So first we'll start with R, which is at 1, 2, 4. I don't want to mess this up. I got a 3D grapher here. So 1, 2, 4. Okay, so that's going to be the midpoint halfway between S1 and S2, because remember, they all lie on the line. And what was S sub 1? S sub 1 is negative 4, 0, 4. So let's go back. Negative 4, 0, 4, plot. There she blows. Okay, so this is R, this is S sub 1, so we should expect S2 to be over here. And what did we get for S2? 6, 4, 4. Okay, so let's take a look. 6, 4, 4. Okay. Oops. Why did I do that? Let's zoom in. Okay, plot. Boom, boom, boom. And at least visually, I mean, you know, we have the cursive perspective here, but I think you can agree that we can be reasonably sure that that is correct just looking at that. Not that you would have that tool in the exam. I just thought it was kind of cool. Okay, so now we're going to find a vector equation of the line that passes through R and bisects PRS1, or we can think of that as vector PS. Okay, so what are we going to do here? Oh, well, I need a point and a direction, but the direction of the vector is going to be RM, where M is vector RM in the direction of vector RM. M is the midpoint of vector RS1. Okay, so then M is going to be equal to, the point M is going to be equal to the average of the coordinates of R and S1. So here's R1 and S1 is negative 4. So that's going to be, wait, that doesn't make any sense at all. Wait, what am I doing? PS1. Sorry, of PS1. Yeah, I'm not sure why that R is there. PS1. So where is point P? Point P is up here, yes, and point S1 is here. So we just find the average. Negative 3 and negative 4 is negative 7 over 2, which is negative 3.5. And then let's see, what would we get for the other two? Negative 1 and 0, so that's negative 1/2. And then 2 and 4 is 6, divided by 2 is 3. So that's the midpoint, that's the direction. So we have RM for our direction would be equal to the vector negative 3, where's R, minus 1. Oh, negative 3.5 minus 1 is negative 4.5. Negative 1/2 minus 2 is negative 2.5. And then 3 minus 4 is negative 1. So that's the direction of this line. And then we just need a point. Well, and it passes through R. Well, R is my point. So you could say R equals, help me, 1, 2, 4. Plus some t times 952. Why did I do that? Well, we like positive values. Just multiply through by negative 2, and you're going to say, well, that's the opposite direction, Mr. Becker. Well, this is the equation of a line, so it's all cool. All right, so hopefully you enjoyed that. I know I did. Let's check out Celtic Woman and Orinoco Flow. We are sailing away. We're doing awesome. Hope you enjoyed it. Sam, you got anything to say to everybody? Louder, Sam.
Bye.
Bye. V squared, you got anything? Nope. She is dominating her anatomy final, and I am out.